In this video, I'm going to work through this limit problem. So first I'm going to check my type, and when I evaluate at x equals 5, I find that I get 0 on the numerator and 0 on the denominator. So this is type 0 over 0, which is an indeterminate form. So I need to change this somehow so that I can get it in a form where I can evaluate the limit. Now here I'm dealing with an absolute value. So when you're working through limit problems with absolute values and you find that you have an indeterminate form, you need to rewrite the absolute value using the definition. So I've gone ahead and written a tip for you to rewrite the absolute value using the definition. And recall, this is the definition of the absolute value. So we can now use that in this problem to rewrite our absolute value. And we're working with the absolute value of 5 minus x. And by definition, that will be 5 minus x if 5 minus x is greater than or equal to 0. And it will be minus 5 minus x if 5 minus x is less than 0. Now, we can rewrite this piece over here in the following way. So we know that 5 minus x is greater than or equal to 0 if and only if 5 is greater than or equal to x, but we normally wouldn't write it like that. The proper way to write it is like that. So I can rewrite this as 5 minus x if x is less than or equal to 5. And I can do the same thing with this part here, and I can rewrite that. Sorry, that should be less than or equal to 5. And so I can rewrite that bottom piece as minus 5 minus x if x is greater than 5. All right, so now back to my problem. So now I need to figure out which part do I use to rewrite the absolute value of x minus 5 in this situation. Well, let's remember, what does that mean? If we're going to 5 from the right, that means x is bigger than 5, right? So in that case, I want to look to my absolute value, which is a piecewise function, and look at the part that tells me that when x is greater than 5, I should use this part of the definition. So let's rewrite this. And I think while I'm at it, I'm going to factor the numerator. I'm going to pull out a 2. And I have x minus 5. And so on the denominator, I have minus 5 minus x. Okay, and I could rewrite that limit as x tends to 5 from the right. That's 2 times x minus 5. And I think I'll pull that negative through just to make it a little more clear what I'm doing. Because if I pull it through, I get 5 plus x, which is x minus 5. And those cancel. And I get the limit as x tends to 5 from the right of 2. And the limit of a constant is a constant. So my final answer is 2. Now, let's say we change the problem slightly, or there's a second part to the problem, and I want to find the limit as x tends to 5. I have to be really careful because this is a piecewise function. It's defined differently on either side of 5, and I'm approaching 5. So what I need to keep in mind is this. So if the right and left hand limits are in fact not equal, then this limit does not exist. If they are equal and they're equal to the same real number, then that is in fact the limit as x tends to 5. So I already figured out that the limit as x tends to 5 from the right is 2. And now I need to figure out the limit as x tends to 5 from the left. So let's go ahead and do that. So the limit as x tends to 5 from the left, I'm going to factor that out. And then on the denominator, so what does this mean? I'm tending to 5 from the left. That means that x is less than 5, which means I want to go over here and I want to use this part of the function, right? So I'm going to rewrite that as 5 minus x. And I'm going to do the same thing I did last time. I'm going to rewrite that as the limit as x tends to 5 from the left. I have 2 times x minus 5. I'm going to rewrite my denominator as minus x minus 5. And this now becomes the limit as x tends to 5 from the left. Cancel those two factors. And I have minus 2. The limit of a constant is just the constant, so the limit is minus 2. Now let's examine what happened here. So we found that the limit as x tends to 5 from the right of f of x was 2, and the limit as x tends to 5 from the left of f of x was minus 2. The right and left hand limits are not equal. Therefore, the limit as x tends to 5 of our function, which was 2x minus 10 over absolute value of 5 minus x, does not exist.